Now let us understand this next problem. This problem says Baron reported that the average number of weeks an individual is unemployed is 17.5 weeks. Okay, so this is a real case problem which is given in front of us. What kind of information we have? Problem says that the average number. Average means mean. So in our case, our mu is equals to 17.5 weeks. Assume that for the population of all unemployed individuals, the population mean length of unemployment is 17.5 weeks. The same information is written in twisted words, and the population standard deviation is 4 weeks. We have sigma as 4. Suppose you would like to select a random sample of 50 unemployed individual for a follow-up study. We are considering the sample size of 50 for this particular study. Let's solve the objective A. It says that show the sampling distribution of the sample mean average for the sample of 50 unemployed individuals. So sampling distribution means whenever it is asking us to show sampling distribution, we will always create a diagram, normal distribution curve. Okay, and we will just show that the mu lies over here and our sigma lies over here. Okay, so this is our 17.5 and this is our 4 weeks. That's it. Next, B. What B says is, what is the probability that a simple random sample of 50 unemployed individuals will provide a sample mean within 1 week of the population mean. As I previously told you, whenever this keyword within comes, you will always solve the problem with the help of normal distribution curve. So in this case, our within is 1 week. That means we will use the approximation method. How are we going to do that? We will do it with the help of mean. Okay, so our mean, which is our mu, is equals to 17.5, and we will calculate our x1 and x2. What we do in the approximation, we use plus and minus. So we will do plus and minus 1 week. We have our average of 17.5 weeks. We will minus it. 17.5 minus 1, 17.5 plus 1. So it comes around 16.5 and this comes around 18.5. Okay, now let's visualize this with the help of normal distribution curve. Here is our 17.5, here is our 16.5, here is our 18.5, and this is our particular range. Okay, the problem is asking us to find out this much portion within. How much? Okay, what is the probability of simple random sample of 50 unindividual employees will provide a sample mean within this 1 week? Okay, 1 week, 1 week. So we will estimate this. How we do this? We calculate two z-scores, two separate z-scores. What is the formula? Z1 equals to x1 minus mu by sigma upon root n. We use the standard error over here, okay, because we are dealing with samples. Same case with here, only the values will change, only this x1 and x2 will change, others will remain the same. So here we have 16.5 minus 17.5 divided by 4 divided by root 50. Same case over here. So this gives us around, so our value for Z1 and Z2 is estimated to be around minus 1.76 and plus 1.76. Now we calculate what is called as probability, okay. So let me remove this diagram and write it over here. So our p-value for z-score, which is less than equals to minus 1.76, comes around 0.0401. Our p-value for z-score greater than plus 1.76 comes around 0.9599. Okay, so these are the two values which we found out. Now we are left with our last step. So in the last step, what we do is we calculate the actual required probability for our within portion. So this is our within portion and we want only the area for this much portion. So we do what is called as highest value minus smallest value. So 0.9599 minus 0.0401, which comes around 0.9198. Okay, means that when we will convert this into percentage by multiplying s into 100, we get 91.98%. So there is a 91.98% chance that a simple random sample of unemployed individuals will provide a sample mean within 1 week. Okay, this is our calculated probability. They asked us what is the probability. This is the probability. Alright, now let's solve the C, objective C. So in this question the problem is same, only the within is changing. Okay, so we will calculate ours x1 and x2 accordingly. So we have 17.5 weeks minus, here we will do the plus, by 0.5 by 0.5. So in this case it becomes 17 and it becomes 18. How this will look like? This is 18. Alright, this much portion is question mark and in the middle lies our mu, 17.5. So this is your homework. You can calculate the probabilities for these two in the similar fashion. x1 minus mu upon standard error Okay, so the calculated values will be your homework, and please do the last step, which is okay, this is the last step to subtract the highest p-value by lowest p-value. Then you get the actual probability. Alright, moving on to the next question. In May 2018, the College Board reported the following mean scores for two parts of the Scholastic Aptitude Test (SAT). Here, evidence-based reading and writing has a mean score of 533. Mathematics has a score of 527. Assume that the population standard deviation on each part of the test is equals to 100. This is sigma. Now, what is the probability? The objective A is saying what is the probability a sample of 90 tests. We have sample as 90. Test takers will provide a sample mean test score within 10 test points of the population mean of 533. It's only asking on the basis of evidence-based rating. Okay, so this scenario is applicable for only evidence-based reading, so we will consider the mu of only evidence-based reading and writing score, meaning that we are only considering the case for the average or the mean value for only evidence-based reading and writing score. So this is our mu, and as the question also said, the standard deviation remains same for both of the cases. So that's it. Now, as within is saying, these are 533 points, and within is asking us for 10 points. So we will calculate the x1 and x2 accordingly. How we do that? x1 equals to mu minus within, and on the other hand, mu plus within. So minus 10. In this case, it is 533 plus 10. So it's 523, and here it's 543. When we visualize this, it will look like this. This is our mu, which is 533. Here lies our 523. Here lies our 533. And this portion is our within, which is question mark. We are calculating only this portion. So same case, we will calculate z1 and z2. x1 minus mu divided by sigma x bar, which is standard error of the mean, x2 minus mu by sigma x bar. So 523 minus 533 divided by, we have sample size as 90, so 100 divided by 90, and same for this case, 543 minus 533 divided by 100 upon 90. So this is your task to calculate this Z score, and after calculating, check the p-value. from set table and do the highest minus lowest p-value calculation. This gives you the within probability. Alright guys, this is it. This is all we did so far. So from the starting till the end, we did everything. We understood about types of population, which are finite and infinite. We also understood about the finite population correction factor. Then we went through central limit theorem. Then we also understood what is standard error of the mean. And then we also understood about some of the keywords which were within, standard deviation of the sample mean or standard error, and between was also one of the keyword. Then we also noted that we denote small n for samples and we denote capital N for the population. Alright, thank you. See you again. Bye bye.